Okay, so today we're going to be learning about how to create and graph functions in two variables. So first off, what's a function? So a function is a relationship involving one or more variables. So we can find out what one variable is if we're given the other. Okay, so here's one relationship we're given. Y, a variable y, equals a variable x plus 3. So whatever x we have plus 3 will give us y. So we're going to show this relationship on an xy plane where y, we're going to show all our y values on this vertical axis here that goes from -11, -10, all the way up to 10 and 11. And then our x values are going to be in the horizontal or sideways axis from -11 to +11. And then we're going to look at some characteristics of what our line looks like. So first, let's pick some values for x and then find their corresponding y values, the y values that match up, so we can put them on our graph. So what I usually like to do is just pick the values. So pick one negative value. So let's do -1 or okay, we can do -2 for our first x value, then -1, then 0, then 1, then 2. So those are just 5 random values I picked, so we can draw our function on our graph after. So now that we determine what we want our x values to be, so you can pick whatever ones you want. I just picked 5 pretty easy ones. I made this table that shows our x and y values. Now we're going to find out what our y values are. So first off, we have x is -2. So if y equals x plus 3, if we substitute -2 in for x, we get y equals -2 plus 3, which is just going to be 1. So for the x value -2, we get a y value of 1. Next, if we just add 1, right? If we do -1 for our x plus 3 would give us +2. 0 for this x value plus 3 would give us a y value of 3. An x value of 1 would give us 1 plus 3 for our y value, which is going to be 4. And then finally, an x value of 2 would give us 2 plus 3, which is 5 for our y value. Now let's go over to our graph, which shows our xy plane. So how we're going to plot this is I'm going to use this red ink over here, and what we're going to do is plot our x value and our y value together. So our first point is going to be -2 for our x and +1 for y, or -2, 1. The coordinate is usually written in this form. So it's always written as x, y, with the x value going first. So this one, for example, would be -2, 1. And what that means is we're going to go -2 on the x-axis, so 1, 2, and +1 on the y-axis, which would put our first point right over here. Next, for x value of -1, we have a y value of 2. So let's go back here, -1 horizontally, +2 vertically, right, for our y value of 2. Then if we do the same thing, so 0, 3, we're not moving at all in our x direction, but we're moving 3 up in the y direction, and so on and so forth. So then you can start to see this pattern happening, which is going to be our line. Next, what we're going to do is show a relationship or draw that line through our coordinates. So your function may not always be a straight line, but in this case, we can clearly see that it goes something like this. I'm trying to do my best, but it's supposed to be a straight line. So now let's take a look at a few key terms. And this line is going to go on infinitely, right? So whatever x value you put in, you're going to get +2 y value. That line is going to go on forever. So let's look at a few key terms that we have over here. So first off, let's look at our y-intercept. So a y-intercept is your y value when your x value is going to be 0. So let's take a look at what that means. So our y value when x is 0. So if we go on our x-axis, our horizontal axis, our x value is going to be 0 right in the middle. Then if we find out what y value that is, if we plug in 0 for x, we can see our y value, right? If we go back to our table, is going to be 3, which is this coordinate right here where it intersects with the y-axis. So this, let's actually make this green. That is called our y-intercept. Now our x-intercept is our x value, oh, sorry, that's a typo, our x value when y equals 0. So that's going to be our intersection with the x-axis. And clearly we can see that happens right over here. When when y is 0, x is going to be negative 3. Then we have a characteristic of lines called their slope, or how steep they are. So what the slope is your change, for every change in y, what change in x do you get? So here we can see the best way to do this is to find a rise over run. So basically what you do is you take 2 points on your graph. So for example, let's just take this one right here, 2, 5, 2 on the x-axis, 5 on the y-axis, and 1, 4, right? And we're going to see how much in between these points is there a change in y and a change in x. So we can see right here, as x goes up by 1, y also goes up by 1. So our change in y was 1, and our change in x is 1. So it would be 1 over 1, which would give us a slope of 1. Slope equals 1. So hopefully that makes sense. We're going to try another example right over here. So let's go on to our next function. 2y equals 4x plus 8. So in the last one, we always want to make our equations in the form of just y on the left side, so we can find out what our slope is, far easier. So right here, we have our table with our x and y values, right? We can start plotting them right away, but what I actually prefer to do is simplify it down. So if you guys saw the video on coefficients and how to simplify equations, you can see that, all of these are multiples of multiples of 2, right? So what we can do is divide both sides of the function by 2. So we divide by 2 on this side and divide by 2 on this side. 2y divided by 2 should equal y. And 4x plus 8 divided by 2, 4x divided by 2 would be 2x. And 8 divided by 2 would be 4. So we get an equation that's y equals 2x plus 4, which is the same thing as 2y equals 4x plus 8, which is divided by 2 on both sides. So now let's do the same thing we did in our table, which is fill in our table with x values and their corresponding y values. So our first one, we can choose negative 2 again. That's usually a good one. Negative 1, 0, 1, and 2 for our x values. And then for our y values, we can choose, not choose, it's based on our equation, right? So y equals 2x plus 4. If x is negative 2, 2x would be negative 4. Negative 4 plus 4 would be 0, so y would be 0 here. If x is negative 1, then negative 1 times 2 in our equation would be negative 2. Negative 2 plus 4 would be positive 2. If we have 0 for x, then y would equal 4, right? Because 2 times 0 is 0, 0 plus 4 is 4. If x is 1, then we get 2 plus 4 is 6. And if x is 2, then 2 times 2 would be 4 for our x. 4 plus 4 would be 8, which would be our y. So now let's quickly plot these points on our x and y plane. So just a reminder, you always want to label your axes. The x-axis is the one that goes horizontally, and the y-axis is the one that goes vertically. So our first point is negative 2, 0. So negative 2 on the x-axis, and we're not moving at all, 0 on the y-axis. So that's one right here. Then negative 1, 2. So negative 1 on the x-axis, and then positive 2 on the y-axis. Then let's do, let's do a couple more. So then 0, 4. So we're not moving at all on the x-axis, but we're going up 4 on the y-axis. And one more. Okay, let's do 1, 6. So 1 on the x-axis, 1 to the right, and then 6 up. Now look at our final point. So now I'm going to try to draw my best version of a straight line through all these points. And remember that line extends infinitely. So that line's going to go on forever. So now we can see, let's try to look at our important key features of the line, right? So first we have our x-intercept, right? So that's our x value when our y is 0. So when our y is 0, it's on the x-axis, right? It's not going up vertically or vertically up or vertically down. So if we look at our x-axis, look at this point. This must be our x-intercept, negative 2, because that's when our y value is 0. Our y-intercept is our y value when x is 0. So that must be on this axis, which is right over here, when y equals 4. Now let's try to find our slope, okay? So what we're going to do is let's take these two coordinates actually right here, the intercepts, and see for how many x values we travel, how many y values we travel. So between these 2 points, our change in x is going to be plus 2, right? Plus 2, because we traveled 2 to the right, and then we traveled actually 4 up. Our slope is our change in y over change in x, so if we do plus 4, right, change in y over change in x plus 2, we get a slope of positive 2. So that's our slope for this equation. And finally, just to review, we write our equation like this. Y equals mx plus b. So y and x are variables again. M represents our slope, change in y. This little triangle right here is a Greek letter, delta, for change. Change in our y value over change in our x value. That shows how steep or sloped our equation is. And b is our y-intercept, or the intersection of the y-axis. So right over here, our intersection was plus 4. And you can see that right here, plus 4. That's our b value. So that's it. I'm going to zoom in right here on the terms again. If you guys want to pause on this page. So our slope again is our change in y over change in x. A y-intercept is a y value when x is 0, and our x-intercept is an x value when y equals 0. And once again, a function is a relationship involving one or more variables. Thanks for listening.